get started here. Quick introduction. My name is Matthew Conlen, and I'm going to be talking about new data viz in data journalism. So I'm going to be covering a range of topics pertaining to data journalism and kind of the charting tools and the interactive tools that are coming out to allow people to create really nice interactive work on the web. A little bit about me. I'm currently a PhD student with Jeffrey Hare at the University of Washington. You heard from some of my lab members earlier talking about Vega Lite. I've also been working with 538, the data journalism website known for their political predictions since the site went to ESPN in 2013. And I'm going to kind of cover two main topics here. The first is I'm going to go through a bunch of examples in different areas that I find interesting and I find innovative and things that I think we should be doing more of. And then I'm going to cover some of the tools that people are using to create these things. But before I get into that, I kind of want to address, I guess, the elephant in the room of data journalism at this point, which is this. And especially because a lot, so a lot of people sort of equate the two, right? Is that the thing data journalists are best known for is trying to predict elections. So you have examples like this from 538, examples like this from the New York Times, examples from this from across many different websites, all kind of failing in one way or another. And so what's the problem here? I mean, we're dealing with a pretty complex topic, and we're dealing with uncertainty and probability, so these things are never going to be right. And so what I want to say is that we have this sort of cascading failure model, which is you go from polls to predictions to design to the reader's understanding of what you're saying. And at any of these levels, you can have failures that sort of come out in the final piece, which is that you give the wrong prediction, essentially. And so what happened this time around was that the polls were off, the predictions mostly were off, the designs were trying to convey probabilities in a way that probably wasn't quite right, and people were understanding them sort of something like this. So you say, if the weatherman gives a 1 in 3 chance of rain and it rains, is that prediction wrong? And the answer is really that we don't know. The answer is, depending on how you interpret probabilities, either the prediction was wrong, the input data was wrong, or the analysis was wrong. In this case, I think people were wrong in a lot of ways, but they did their best with the data that was provided. And people also tried to convey the uncertainty that was inherent in these problems. For example, this is showing the simulation results from 538's model. And so you can see that most of the results show a Clinton win, but there's a substantial, about 30% of them that show a Trump win. Additionally, this is showing the expected outcome of the Electoral College. And you can see, again, expected Clinton's win, but you get these error bounds, and the error bounds are overlapping pretty substantially. So we're showing these chances of the outside event, but unfortunately, mostly people just saw this, which is 70% chance of victory, and I think maybe readers see something that's greater than 50%, and they just assume that that is more or less what's going to happen. There's some other kind of interesting innovations that came along this election. This one got a lot of both praise and heat from different communities. This was, I'm sure you're all familiar with this if you were watching the election night. These spinners are varying in real time with the results that came in, but they're not actually showing like a new vote being registered or read. What they're showing is the uncertainty in the current estimate. So they'll vary from the 25 to 70% confidence intervals randomly. And what the designers at the New York Times were trying to convey is that, at the beginning as the results are starting to come in, these things will shift a lot, and as the results continue to come in and the uncertainty becomes smaller and smaller, the jumpiness of the needle will go down. Unfortunately, people took it slightly differently than this. They read through the source code and they saw a math.random, and then they just said, well, they're lying to me. This is not really what's happening. And yes, there is a math.random in there, but it also is based on solid statistics. So this is another point where we're designing, trying to convey complex ideas, and maybe this is a failure if either the readers didn't understand it because it's too complex or because the design was misleading. It could be a variety of different things. So here's a comment from Twitter from Gregor Eisch, one of the designers at the New York Times, trying to defend it, and someone responding by saying, oh no, that is just garbage. I don't know, I'm sympathetic to the New York Times, but I spend all day looking at these visualizations, so. All right, let's stop talking about that and start talking about some of the things that I like. These were two things from the 538 that I thought were really nice. The map on the left is from Ella Cozy. It's a handmade map showing the scale of the Electoral College votes of each state. And the graphic on the right is this kind of snake shape by Aaron Bykoff that shifts to the left or right and shows kind of like where the dividing line is between wins as states shift from the left to the right. This was a piece from Rich Harris that used the Regal framework that you heard about from Akola earlier. In typical Rich fashion, he describes the Guardian's election map as zoomy as fuck, which I think is accurate. And here's a piece from the Wall Street Journal that was published a long time before the election actually occurred, but it's especially, I think, important now with all the conversation happening around fake news on Facebook and all these things. It's essentially it lets you see the Facebook news feed through the lens of a typical Democrat or a typical Republican. So you can say, I want to click on Barack Obama, for example, and on the left, on the liberal side, you'll see stories that would come up and stories that would be seen by someone who is a likely Democrat on Facebook, and stories that are seen by someone who's a Republican. And they're quite different. I mean, this screencast is from after the election, so you have a lot of things about the protests about Trump, and the left ones you can see are, oh no, protesters are arrested, all these things, there's massive protests. On the right, it's kind of these terrible protesters should be stopped and yada, yada, yada. One topic that is, I think, especially important and will be continued to be thought about for a while is this thing of uncertainty, especially with elections, but also in a lot of other places. Really anywhere that you're dealing with sampling or polling, real-world data is very messy. We have confidence intervals there for a reason, but it's very hard to actually convey that. This is work from Jessica Hallman at the University of Washington, something called a hypothetical outcome plot. On the left is a typical box plot showing the range of possible outcomes with the confidence intervals in the dotted lines. On the right is this concept of a hypothetical outcome plot. So instead of showing explicitly the confidence interval, you're sampling and showing different potential results. So as they come in, you kind of build up an idea of where the mean is and what the range is in sort of fluctuation. This is, I mean, it's very related to what the New York Times was doing with their spinners. It's just a bit more explicit in this case. This is something not directly uncertainty, but dealing with how different data can sort of take different forms. This is a piece from the New York Times covering the jobs report, which is a monthly report that essentially tries to convey the state of employment and the economy in some ways. And so they do this nice kind of interactive animating piece where they say, okay, if the job growth was steady, was actually kind of a flat line over the past year, what you would expect from that is on the left, but here's all these different examples of different potential sampling points that could have brought about the same exact result. And it just goes to show, I mean, if you're looking at data that's being delivered to you every single month, then maybe the small fluctuations month to month aren't quite as important as the long term, or maybe they are. Here's an example of what it would look like if the growth was accelerating. Again, you have all of these different potentials on the right that don't all quite paint the same picture as the static one on the left, although they're all showing exactly the same slope over 12 months. So one thing that I think is pretty interesting and related to this is that we can do simulations. So instead of just saying, all right, here's my confidence interval and here's the static result, instead I'm going to take the probabilities that I know and actually run a simulation in the reader's browser so that they can sort of understand, all right, here's one result, maybe they can run it again and see what happens over time. And this is really good for showing people patterns, especially where the math is extremely complex and probably not as important as really the final result. It's a great piece from The Guardian showing vaccines, and what it's displaying is in the circles are different groups with different levels of vaccination rates. And so these red dots kind of come in and they're essentially the vector of the measles virus. And either it hits someone with a vaccine and it sort of gets rejected from that population, or it hits someone who's not vaccinated. And you can see that based on the percentage of people with the vaccine, you get very different results. So on the top line, it's going in increasing order. So in the top left is the least vaccinated population, and the bottom right is the most vaccinated. You can see even with about 75%, you'll get a lot of outbreaks in that population. So you have to have a really high vaccine rate to prevent the disease from spreading in your population whatsoever. It's not enough that just most people have it. This is, again, a simulation that will run in readers' browsers, taking into account all of these complex probabilities and showing it in a pretty intuitive way. This is an example that I worked on at 538. This is a simulation of the parole system and how different assessments of prisoners' likeliness to commit another crime after they are released is taken into account, and how that affects the actual recidivism rates and the sort of wrongly given results by the judge. So in the left, in the kind of petri dish looking thing, is the prison population. They're assigned a low, medium, or high risk score of whether or not they'll commit a crime again. And then based on that, they're either awarded parole or they're not. And of course, some of them who are awarded parole will recommit a crime, and some of them who weren't awarded parole wouldn't have committed a crime, so they're kind of wrongly kept without parole in that case. And what this allows the readers to do is change the thresholds at which the low, medium, and high probabilities are assigned. And that's essentially it's simulating a policy decision. So this is something that's essentially just a number on a piece of paper, which is, here's the risk score, and how do we categorize you? And that moving that number around has a huge impact on these people's lives and what happens with the population. So this kind of lets you see, all right, what trade-offs am I okay with? Am I okay with keeping more people in jail or having more people recommit crimes? And again, this is something that involves a lot of different sampling distributions and some complex math that is not really important to the idea that's trying to be conveyed here. This is another simulation. This is from Nathan Yao on flowing data. It says, how am I going to die, I think is the name of the piece. And it runs a simulation where you say, okay, I'm a white 23-year-old female. All right, start now, and it's going to have this population, and it's going to show you how the people in this population die over time. And so you can see when it just starts off, it's kind of mostly external causes and things because the people are young in this case, and then as time continues, as we get to 60, 70, 80, 90, 100 years, cancer becomes more likely and circulatory problems become more likely. Another interesting kind of space, I dub it boutique data in this case, which is really just people who are using sensors or creating their own data sets in some way or another. So as sensors are becoming cheaper and cheaper, so journalists are starting to have more and more access to them, and also open source toolkits are becoming better and better. So people are able to collect their own data, create their own data sets, and I expect to continue to see more and more of this into the future. This is something that I really liked. It was posted on the Data is Beautiful subreddit. This is a graph of someone's heart rate during public speaking over time. So you can see the spikes as they begin, kind of calms down throughout the talk as they get comfortable, spikes again at the questions portion. They might have gotten a tough question. But this is just something that someone did with a personal sensing device. And it tells, it tells you the story that you would kind of expect, but it's really interesting to see it with this raw data. It would be interesting to see it with really seasoned speakers as well, how it changes over time. This is a project from ProPublica, and I think it came out in 2014, so it's basically ancient at this point. It's called Losing Ground. This is an analysis of the sort of receding shoreline in Louisiana. And the way that they did this was by taking satellite imagery and running some analysis over time on the satellite imagery to actually see, like, here's how many feet of shoreline have been lost in these different areas over time. So they didn't send satellites up, but they used the satellite imagery to create this new interesting data set, which is the shoreline change. There was also a related project from Reveal last year that was analyzing the drought in California. They looked at satellite imagery and they looked at the colors of people's lawns to actually figure out who was using the most water during the drought. And it turns out that there's some people in Beverly Hills who are just using like obscene amounts of water. And they did all this just by looking at sort of the color patterns in the satellite photos. This is another interesting one. If you remember last year, there were some riots in Baltimore. Someone noticed during the riots that there was a plane circling above. And then people got really interested in this, and they realized that with some kind of personal homemade hardware, you can actually track planes and sort of the pings that they send to control centers. And so this person just kind of hacked together this thing and was able to actually track these FBI surveillance planes as they were flying in the skies. This led to another project which was done by BuzzFeed. BuzzFeed, I don't think, used their own sensors for this. They used another data set. But all these red and blue circles are from surveillance planes over New York in this case. The red is the FBI and the blue is DHS. So here's the planes after the San Bernardino shootings. You can see that they concentrate on the mosque. All right. Another interesting area, I think, is people are starting to get back to basics. which is really nice because with data visualization, really what we're trying to do is actually convey information to people. So it's not always necessary to have crazy complex interactives and really flashy graphics. Sometimes you just need to have the data presented in a clear way, and sometimes pen and paper is the best for that. This is Mona Chalabi's Instagram account. She's a reporter with The Guardian and formerly at 538. She posts all these hand-drawn, kind of nice graphics of different data sets, a lot to do with kind of the human body. People may have seen this project from David Fahrenthold. He was looking at the charitable donations that Trump had claimed to have given and basically live tweeted his whole research process during this. I think he looked at 400 some different charities and just posted list after list as he called, and most of them were never donated, never heard of that. His final update after 6 months of doing this was there was one donation between $5,000 and $10,000, but asterisk, maybe a bookkeeping error, so we're not sure. This is a nice project from Giorgio Lupi and friends called Dear Data, where she exchanged postcards kind of every week, dealing with her day-to-day life and just making little interesting data visualizations out of them. So more data visualization as art type thing here, but still pretty interesting. One caveat with all this is that it's really easy to forget that the subjects that you're working with in data journalism are actually real people and not just dots or lines or numbers on the screen. So just make sure you're considering the impact of what you're doing and how it affects real people's day-to-day lives. So a few examples of things that straddle the line. I think they actually do a good job, though. This is from the Tampa Bay Times after the shooting. They actually do a 3D kind of play-by-play of what was happening. And so this is really intense if you were close to the shooting at all. They actually go just like minute by minute everything that happens from the stories that they gathered. Again, I think they do well to make sure they're humanizing the situation, but again, it's easy to get lost. This is a project from the Marshall Project called The Next to Die, where they have a website that you can go to that has information about every single prisoner who's scheduled for execution, has background on them, and it has a real-time kind of countdown of when it's going to happen. It's kind of hopefully giving a voice to people who are more or less forgotten by society in this case. And Josh Begley's work also applies here. He does a lot of kind of, I guess I would call them rhetorical data visualizations, where you just present sort of this like brutal list of images. So this is called Officer Involved, and it's Google Street View or image of every single place that a person was killed in a shooting by a police officer I think it was in 2015. And so again, we're not really saying anything about the numbers here, but just the sheer volume of images that continue to come as you scroll are making a point, and you can see where these things actually took place. His most recent project was called Best of Luck with the Wall. I'll show you a quick, hopefully I can show a quick video. Oh, I may skip this in interest of time, but basically what it is he takes a video of the entire US-Mexico border, all however many thousands of miles there, and it's just an aerial overhead video of the entire thing, and it lasts for about 7 minutes, and you can see every single location across the border. Again, kind of a rhetorical piece. Other interesting wins, I'm going to skip over these and get to the tools just because I'm running out of time, but the 538 broke a scandal with crossword plagiarism abuse, and BuzzFeed sort of exposed this whole racket in the professional tennis by analyzing different numbers. They figured out that a lot of match fixing was going on. The really cool thing about this is that they posted all their analysis on GitHub. You can actually see their Python notebooks and how they figured out that the matches were being fixed. So one thing that gets into is this tool called Binder, which is really awesome for reproducible data science like this, is that what it does is if you have a Jupyter notebook, it's typically static when you post it on GitHub. This essentially turns it into a live notebook that people can just go to a URL and start using. So here's an example from BuzzFeed, again, a project on refugees where they posted a notebook, but then in the README, they also say, alternatively, you can just run the analysis in the browser by clicking this link. So that goes to Binder and just gives you a live Jupyter notebook that you can use, backed by this kind of Dockerized compute engine that you can just have access to, which is really nice. Chart Builder is an open source tool from Quartz, which a lot of other newsrooms have since picked up and started working on. It's cool to see collaboration across different newsrooms like this. Basically, you can paste in CSV files and it'll create a chart. The really nice thing about this that I think is sort of underappreciated is that it lets you just do a very constrained set of charts, so you can do line plots and scatter plots and things like that. But it's good for reporters who don't necessarily have the best design skills because they can only do things that you say, okay, these are reasonable charts that someone should be making and putting in a story. You can't do anything crazy. Another couple just interesting tools to be aware of if you're doing this stuff. Mr. Data Converter is a website that you can convert pretty much any JSON, XML, CSV, tab delimited files between any other format. So if you're tired of writing scripts to do this for you, you can just paste it in this website and it'll do it in like 2 seconds. Similarly, there's MapShaper, which is an online tool for dealing with geodata. So you can start out with, kind of this crazy, ugly map of the US and shape it, mess around with the colors and everything, and end up with something that you would see published. Dataproofer I actually haven't used, but it's backed by some smart people at the Knight Foundation and at Vocative. What it is, it's essentially unit tests for your data, so you can make sure that there's some integrity as things change, and you make sure that there's some sanity checks if you have static spreadsheets or CSVs or anything like that. There's a couple of election tools I wanted to point out. Huffington Post has an API for pretty much any poll that gets published. It's called Pollster. You can use Python or R or whatever your favorite client is and just download the results. And the New York Times released Elex, which requires a subscription to the Associated Press, but it's essentially code that every newsroom was writing before every year and was so much wasted time, and now there's just one tool that does it for you, so you don't have to worry about it anymore, and it's like open source, saving people time, which is really nice. And finally, TerraPattern is a project from Kyle McDonald and some people at Carnegie Mellon that allows you to basically search geographic images. So in this case, I would look, if you see in the bottom right, like I would point out, okay, here's a ship in the harbor, and then it would show me the location of every single other ship or every single other thing on the map that looks like that ship. So it's this really cool automated geo search based on what you give it. So you don't even have to give it, you just click on the map and say, I want things that look like this, and it's super easy to use. You can do it all in your browser. And then finally, because preserving these things is important, Web Recorder is a great tool built by Rhizome, one of my former employers, that it's sort of like the Internet Archive, except that it records all of the web requests as well. So if there's any AJAX or anything or Flash that's happening on your page, then it can record this and make completely standalone pages that will last hopefully forever. That's all I've got, so thanks for listening. and I'll take any questions.